Okay, so that was for market demand. And now we're coming to the second part where we try to see the difference in the price analysis between very short run, and long run. The first one is very short run, but let me put it down first, the different things, and then we repeat it again and again just for you to remember. So very short run, the main assumption is supply no supply response at all. So you see here supply is a vertical line, always fixed at a certain quantity Q star, no more, no less. Now, then we have short run supply response only by existing firm, firm, not firm, in the market. Now, no new firm entering the market. And then the last one, long run. And we have supply response both by existing firm and newly entering firms. Okay, so these are the key different assumptions of very short run, long run, and short run analysis. Now let's go to the first one, the very short run price determination. Was actually pretty simple because, like I said, supply always fixed a certain quantity. Doesn't matter how much is the price. So it's a vertical line. Therefore, in this case, supply just play the role of rationing the demand, nothing else. And in analysis, pretty limited. Normally just applied for example, in agricultural economics context for perishable commodities like vegetable or fruit or something which is processed already and you can't carry over to the next period, something like that, because supply is fixed there. Even, for example, in my research narrow field, I study about option and futures trading for agricultural commodity market. So we could have analysis, it's called real-time analysis, and it's counted by second. So you have price change and trading volume changes per second, not even minute per second. In this context, still, you see supply react very promptly. And it's not fixed in like this assumption. So therefore, it's limited relevance in analysis. However, I could give you an example. Back to the time I was small, lived in a rural area of Vietnam, and sometime there were some small fair, with games and concerts and lotteries, all kind of those things. They come over the village and stay there for a few days or something, and everyone could go there and entertain themselves. So, so in those occasions, my mom would take the chance, give me a box of fruit, which were cut already, in pieces, and cooled in ice crush. So then I will sit in front of the fair with other kids in the neighborhood. They also sell something, homemade yogurt or drinks or so on. And because those things was kind of prepared already, we have a fixed amount, a fixed quantity of good that we're supposed to sell to the people who coming to that fair on that day, because fruit is cut already in tropical area. You can't just carry it over and back to the time with small technology is also limited. We rarely have fridge. Okay, so that was that. And doesn't matter at the end of the day how much I receive per portion of fruit that I sell. I have to sell it off, right? Because I can't keep it until tomorrow, right? So supply fixed. On the other hand, if that happens to be a hot day and people come there and thirsty and they find cool food attractive, they might increase the demand. Like in general, the demand will increase. So that will cause a shift upward, right, of the demand. And what will happen? So the price I receive will increase a little bit. I was clever, maybe, because I realized that people wanting my fruit. However, I can't increase the supplies. It's there, because my mom already went to the market in the morning and there's no market later during the day for buying more fruit or getting off from the garden, for example. So that's the case, those limited cases where you have supply fixed. Okay, the very short run was easy, not much to say. However, now we come to the second one, short run, which is more interesting to us to some extent. Now, in the short run, we assume that the number of firms is fixed. That's what we said. However, there is supply response. How? It can be adjusted by changing, in either increasing or decreasing the input to the production process, so that the output quantity change. This we also came across when we talk about production and supply already. Okay. One example is back to my village. My neighbor was selling sugarcane juice. You know sugarcane, like the plant from which they produce sugar in tropical area. Here in Europe, people mainly use sugar beet, but in my country there was sugarcane. Okay, and actually, the fresh juice from this plant they could sell together with ice as a drink, together with either lamb juice or mandarin juice, a little bit inside, very tasty. Anyhow, so because if you want to sell sugarcane juice, then you need a certain tool or machine in order to extract the juice. Yeah. So in the short run, from one day to the other day or from one week to the other week, it's hard for other people, for example, to enter the market just because that week is especially hot and people feel like to drink more sugarcane juice. Yeah. So that's hardly happens. And because of that, no firms enter the market in a short run. Okay. However, my neighbor, the one currently selling the juice, can always get more sugar canes from his supplier and then just sell more to the people every day from one day to one another day or from one week to the other week or even within the day, right? Because we have the supplier in the village. So that's the idea. So we need several assumptions in order to set our analysis in short. The main theme of this assumption is perfect competition. In specific, we assume that there's a very large number of firms producing the same goods. Let me stop here a bit. So back to this point. We have to keep in mind one thing is it's just not about producing more or producing less that make the supply changes. In the case of storable commodities, like the case of soybean and corn market, which I'm studying for my dissertation, these are storable commodities. So you imagine in a short run, once the seed are planted on the field already and before the harvest, there's no more supply entering the market, right? However, because storable, it must be in stock somewhere. And when price changes, for example, when price increases, the one who holding these stock amounts could decide to release it on the market. For example, in the case of China, when they have inventory government reserves for corn and soybean and the market price is high, they could release this stock. In the case of Vietnam, it's rice reserve from the government. When there was a rice price crisis back to 2007 or 8 or something, they also released the stock reserves into the market in order to cool down the market. On the other hand, if the market is there's a lot of supply on the market, then the seller could also decide to keep back part of their product and wait until the conditions better or the supply is scarcer. And then they will release the stock again. Yeah. So that is one case. It's not just adjusting the production, but they could adjust the inventory for those commodities that's storable. Okay, let's go back to our assumptions. So the first assumption is producing homogeneous good. For example, if the farmers in the US and in South America, they produce corn and soybean, there are many farmers in these countries producing soybeans and corn, which is quite homogeneous at the end already. The second assumption, firms attempt to maximize profits. This is an important assumption which you should keep in mind, and that would be helpful for our analysis later when I show you on the board. We'll go back to this now. Corresponding to the number of suppliers, we also have multiple number, large number of demanders. Why not consumer but demanders? Because it could be that the one who want to buy or to hold these goods, not necessarily the final, the end user or the consumer of the goods. Back to the case of soybean and corn, a lot will go to livestock production. So they actually bought by other farmers, either in that countries or other countries. And some goes even into biofuel production, right? So those factories will also be demanders, but not consumer. No? Okay. Next assumption, firms and demanders are price taker. So this is another important assumption to get together with the profit maximization. What the implication of that we see later. Okay, information is perfect. Price is known to everyone. So assuming there are no friction in the market or no private informations, and transactions are costless. So there's no transaction fees and such things. Now, from observing the reality, maybe from your own experience, from reading and watching on the media, you may say, hey, this is ridiculous. It's impossible, right? There's no such things called perfect information. Some have information quicker than the others. Okay. Or transaction fees a lot everywhere. Even when you trade on stock market or like oil markets, you have to pay something, right? This is ridiculous, impossible. What are we talking about now? Remember, these are perfect competition. And that's just the assumption in order for this model to work. Okay, so now I'm not telling you to convince yourself that this is the truth. This is the world that we're living in. No. For example, I myself, when studying about this option and future market, I don't believe that the market is perfect or rational at all. However, at this stage of your education, it's necessary to learn clearly, okay, this is that, these are the assumptions that make the model work. Now, then later, when you want to show that, okay, hey, the work is actually working in a completely different way, then you have to know what you're criticizing about. You have to know clearly what you opposing. That's important. So right now, just keep that in mind. This is the assumptions of perfect competition, which we need for partial equilibrium models and not the reality. Okay. Okay, I jumped ahead a bit before previous slide ended because I think it makes more sense to show this formula when we're talking about it now. So assuming we have a short-run supply function from I forms, and each of these short-run supply function is a function of market price, the price of input. However, here remember, it's just variable input price. It's not every input. No. And then a fixed capital quantity. You remember last time when we talk about short-run supply, we also have a fixed level of capital inside. So now that is this. Oh, sorry. No, so this is the fixed capital level in short run. No, like the machine that my neighbor and his current competitor in the sugarcane juice market, for example. Okay. So now what would we do in order to arrive in the market supply function? We sum up all the individual supply functions, all the individual supplies of each firm, right? And it's very similar manner to what we have seen with the demand side, right? However, the graph here looks a little bit disconnected, not completely seamless like before with the graph of the demand. Why? Now, so for example, you have firm A now, which is willing to produce at this price already, let's say P0. Now, because remember where we had a graph where there is short-run marginal cost and short-run variable cost. When we talk about supply before the Christmas holiday, go back to that slide. And there you will find the explanation for why it's for this form is there, but for the other form is upper. But for now, just pay attention about, okay, that form A willing to produce at price P0, but from B only produce when price P1. Okay, so when you sum up horizontal, the part from B0 to P1 is only the quantity of form A, because form B produced nothing within this price range, right? And then starting from P1, from here, supply of the market includes the supply of both from A and from B. So that's why here is disconnected like that. For supply side, we also have some elasticities, which is similar to what we've seen before, but just now for the whole market. So own price, supply elasticity, remember we're talking about short run, equals percentage change in the quantity supplied, the aggregated already, divided by percentage change in price. And mathematically, that means the first derivative of market supply with respect to P, and then time P divided by QS. Nothing actually new here. The second is input price supply elasticity. So it shows how supply changes when input prices changes. Now, for example, how much more or less my neighbor will sell of sugarcane juice when sugarcane becomes more expensive, for example, during the non-cropping seasons. So for that, we will take the derivative, the first derivative of the supply with respect to W, the price of variable input cost, price, sorry, not cost, let's say price precisely, times that input price divided by supply again. The last thing is for the last argument in our market supply functions, fixed factor short-run supply elasticity. No, even though we said the factor K capital is fixed, it's still possible to derive the elasticity with respect to K, in a similar manner to before. Let's do an example of aggregating the supply across the market, just like how we did that with demand side. Okay, so now here we have a short-run supply function from Cobb-Douglas production function, which is given for market price, input price here, also only labor now, and K1, the level of capital fixed at short run. You still remember? Or no? And then let alpha equal beta equals 0.5. W equals 12 and K1 equal 80. Now, why do we need these numbers? Because if we want to graph it on a two-dimensional graph of Q again P for the market supply later, we have to fix other variables somehow, right? This we know already. Then we substitute this value inside the short-run supply function of each firm. We would have Q as a function of P, W, K1 equals 12 over 0.5, right, to the power of minus 0.5 over 1 minus 0.5. Times K1's 80, alpha is 0.5, sorry, over 1 minus 0.5 again. And then times P stay the same. 0.5 divided by 1 minus 0.5. That's the exponent of P. Okay? Now let's simplify it. So that is 12 over 0.5 is 24, right? 24 to the power of 0.5. In the denominator you have also 0.5, so but minus before, so that is minus 1. Let's separate them by bracket. Then 80, similar but without a minus, the exponent, so this is to the power of 1, times P also to the power of 1. Then at the end, that will be 80 over 24 P. So we could rewrite it here again. P W equals 12 and K1 equals 80, right? Which is now 80 divided by 24. Could simplify it to 10 over 3. Now, why 10 over 3? Divided both the numerator and the denominator for A. Now, times P. So this is the individual short-run supply function, and now we only allow P to vary while holding W and K1 constant. Now assume we have 100 identical firm. Identical meaning these firms face the same output price. Output price and input price. P, W. What to do? Remember from the demand side, the market demand. Then we have market or industry supply, but short run. Supply function. QS, right? This is the notation, equals summing the quantity across all firms in the industry, which is 100. QI. PW equals 12, K1 equals 80, right? And because they're identical, we just simply multiply 100, the number from with the individual short-run supply function. So we would have QS as a function of P when we fix W at 12, K1 at 80, which is 100 times 10 is 1,000, right? Over 3 times P. So this is industry short-run supply function. Now let's try calculating the own price elasticity of the industry supply. Own price short run supply elasticity of the industry. So we're talking about the total supply of the industry itself now. E of supply with respect to P equals the derivative of QS with respect to P times P over QS standard. So here, QS. So the derivative of it with respect to P will be 1,000 over 3 times P over QS. Let's write QS like this so that we could simplify something over there. 1000 over 3 times P. Now let's simplify. 1000 gone. P is gone. 3 here, 3 here. Everything simplified. At the end we have 1. So that's the on-price elasticity. You may have guessed this result already by looking at the functional form of the industry supply now. Just a linear function with 1p over there. Alright? Now the next thing I would like you to think about is what happened when, for example, instead of W equal 12, now we have W equal 15. What happens then? Let's try it out. We need first to go back to QI. Now, starting from QI. So in that case, we would have QI, P, W is now 15, K1 remains 80, equals. That's the reason why I wrote it down this way here. So that's easier for us to process this step. Now, instead of 12, we have 15 over 0.5 to the power of minus 1 times 80 to the power of 1 and p to the power of 1. And that means at the end we have 80 over 15 divided by 0.5, that is 40, right, times p. And you could simplify it. Let's write it out here. By dividing both the numerator and denominator for 10. A over 3 times P. Okay? So, again, just like before, because we have the same number of terms and they identical in input and output price, we have QS, function of P, W is 15, K1, 80, equals 100 times A over 3, P equals 800 over 3 times P. Now, this is what happens when W increases. Now, the next question is, can we aggregate QS as a function of W itself? Answer is yes. But before we need an assumption, which is other values that is K1, alpha and beta remain the same as before. That's what it means. No? Again, we need to go back to the form supply. Now we have P and also W with K1 equals 80, the same. So that would be, instead of 12 over here or 15 over here, we have W itself over 0.5 to the power of minus 1 times 80 to the power of 1 and p to the power of 1. Okay? And that we could simplify it because you have 80 and here you have 0.5 to the power of minus 1, meaning times 0.5. That is 40. Yeah. W minus 1 rewrite, P to the power of 1 rewrite. And this is the individual supply function as a function of W and P. So we would again write the aggregated supply QS P W K1 equals 80 equals 100 times 40 W minus 1 P. I can get rid of to the power of 1 already, not really relevant, and that will be 4,000. No? W to the power of minus 1 and P. So this way we could write the aggregated supply of the industry as a function of W apart from P. Now let's check if we have done everything correctly. So when W equals 15, for example, like in this case, then if we substitute into here, we have QS equals 4,000 times 15 to the power of minus 1 times P, and that is exactly 800 over 3 P. Same result as here.